Welcome. Thank you so much for attending. I know it's a late talk, so appreciate everyone sticking towards the end of the day here. I'm Joe Spisak. I see a lot of friendly faces in the crowd. Great to see everyone. As you mentioned, I'm currently at Meta, leading our generative AI open source efforts. I am a boomerang, so I loved Meta that much, I had to come back. True story. It's an awesome place, and open source and open science are definitely in my blood, so there's not much of a better place to be than Meta to do that kind of work. So agenda-wise, I'll cover a few things. A lot of this is my perspective, kind of being involved in the open source space for a while now. I'll lend a little bit of what I've seen and some of the shifts over the years. I'll talk a little bit about Meta AI and FAIR, again, one of the more open labs that's out there. I've had the privilege to work on a number of projects, not only in open source code, but also actually leading research teams in areas like protein folding and AI-guided material discovery, where there's actually really true impact that's coming from this work, which is really exciting. And I'll talk about the Llama ecosystem. It's not really just a model anymore. It's kind of becoming a platform, so I'll talk more about that. And then I have my friends from Google here, which I'm going to give them some love. I was just at Google the last several months working with teams over there on cloud TPUs, as well as building an LLM platform. So I'll talk, actually get into some code, which is kind of cool. And then the real experts here, like Alan and team, actually, Alex, are here to answer your real questions. But I will actually finish with ways you can get involved. So actually, all of the code I have in this presentation is open source. And I'll actually send pointers. You can read the paper. You can actually check out our responsible use guide. Basically, everything I have here, you can actually interact with and play with and actually use for yourself. So the Gen AI wave. I won't waste your time by talking about how crazy it is in Gen AI. It's been a wild, I would say, 6 to 8 months, probably 10 months. I do use Google Search Trends as a way to look back on my career and kind of gauge, though, like where ML has been. And when I got into ML, it was right around, I would say, just after the ImageNet moment. How many people actually recognize or remember that? Anyone? Okay, so anyone even know what ImageNet, or some people don't even know what ImageNet is? Okay, all right. So ImageNet, when that happened back in 2012, and we went from feature engineering all the way to learn representations, like that shocked the machine learning world, frankly. And you can see it didn't do a whole lot to search trends. It took 10 years, frankly, to get into the mainstream consciousness. It's, by comparison, taken maybe 6 to 8 months or 10 months for LLMs and Gen AI too, which is just absolutely wild. And I've seen kind of the last 10 years and these shifts, and it just baffles me. And I'll talk more about how that's changed over the years. If you look at AI, though, and you look at it over this long timeline, I definitely was not around for the first couple of bullets here. The Dartmouth project, The Logic Theorist, as well as the MIT project, ELISA. If you fast forward, though, past Mr. Kasparov getting beaten by an AI on chess, we're now at the point where generative AI is pervasive. It's everywhere. And the cool thing is there's been this underlying current of open science and open source, and Meta has really been a big part of it. If you look all the way back to 2004 when Facebook was launched, and they started with an AI-powered newsfeed. Jan LeCun in 2013. I remember we were trying to recruit Jan to the company I was at the time, and he went to Facebook instead, which mixed feelings, but glad he's at Facebook and Meta. In 2016, PyTorch was developed on top of the LuaTorch project. And then 2023 kind of became the year of the model, at least it did for us. So Llama 1 was released in February, Llama 2 in July. In August, we actually released Code Llama, which I'll talk about later on. I have a slide on that. And then we're also releasing models like the Segment Anything model, which is pretty amazing. Basically, one-click segmentation of any photo or video, again, all in the open source. So, one of the things I find personally interesting, maybe some others don't, I find that the workflow evolution really interesting in the space. So going back to the ImageNet moment, and this is going to be an age-weighted reference, I guess in Silicon Valley terms, maybe not so much. I don't know. Does everyone remember hot dog, not hot dog? Okay, all right. So we had a writer at Facebook, Colleen Henry, who wrote part of the show, and she actually wrote herself into the show, which I thought was pretty funny. But if you can imagine, 6 whatever years ago, we were basically dealing with large neural nets and people hand annotating data. So whether it's images or the sentiment of a piece of text, we actually had to live in this world of supervision for quite some time. It seems like an eternity ago. But it did bring a ton of value. I mean, supervised models, CNNs, were deployed all over Facebook, all over Google, all over a lot of big companies. It created a ton of value in academia, a lot of research. And it persisted for a long time. And actually, there was, again, a ton of value created. In 2018, I actually don't think people really realized what happened in 2018. I think we're still trying to comprehend, 5 years later, the year of the transformer. So when Noam Shazir and the folks released the attention paper and the multi-head attention and the transformer model were born, we looked at it, we said, holy God, this thing is so expensive to train and deploy, we're never gonna be able to use it. Let's go back to using LSTMs or whatever, which was painful. But the fact is we could do this thing called unsupervised pre-training or pre-training of unlabeled data and then be able to fine tune and actually change the game quite a bit. Even though it was really, really expensive for us to deploy, it actually hit the state of the art on a number of tasks, which kind of gave us a hint of what's to come. And the 2022, I like to call the return of the human, I guess, which is, we had this paradigm of the transformer and unsupervised pre-training and SFT, supervised fine-tuning, and then we brought the human back in it with RLHF, and actually even human evals. And what this actually has created is a new state of the art in assistance, personalities, content creation. We can now generate PowerPoint presentations or Google Slides or videos or images. And it's absolutely amazing what we can do. And if you fast forward, this is an old image. I have a new one in the works. The model has actually become the platform. So I think literally within 2 or 3 days of Llama, the initial Llama release in February, a model was tuned by the Stanford team, the Alpaca folks, and then released. And it has spawned just an incredible amount of innovation, whether that's different languages, different domains. It's become something that is a new level of abstraction that used to be kind of at the framework level, and now it's actually at the model level, which is actually, it sounds kind of trivial, but at the same time, it opens this technology to just about anyone. And so you can prompt engineer a model as easy as asking it questions or posting your prompt or asking it to answer you in stepwise format. And you can actually adapt your models pretty quickly and pretty robustly to a number of different applications. And of course, you can always do SFT with your in-domain data. And it's getting easier and easier to fine-tune these models with services coming and hosted models and so on. So actually, I like to look at this as the kind of the revenge of the model zoo. Does everyone remember the model zoo of 10 years ago or 8 years ago? We all had this promise of the cafe model zoo, and then it really took off, but the model has actually become a platform, which is kind of cool. So this talk is about Llama, so I want to jump into what Llama is and get into some of the details. So has anyone played with Llama, perhaps? Okay, a lot of hands. Has anyone actually done any kind of SFT and actually customized a Llama model? Okay, a few folks, cool. So Llama at the highest level is a large language model, of course. Llama 2 is. It comes in a couple of different variants. There's a pre-trained version, and then there's a fine-tuned version for chat. We call it Llama 2 Chat. If you compare it to Llama 1, which is a 65B, it was trained on 40% more data and has a 2x context length. It also incorporated 1 million human annotations. We fine-tuned it. And at the time, of course, this is a moving target, it outperformed many of the open source alternatives. Now, of course, there's new models like Falcon 180B, which is a beast of a model. That's out there these days, and new models are coming out all the time. But it's still actually a pretty impressive model. And if you go to the Open LLM leaderboard for Hugging Face, it actually is the top on average across the benchmarks, still to this day. Still, and I say that after it's only been released for 2 months, which is kind of crazy. So, we thought about this. We thought about the progression of these different types of flavors. The two we released were really the brain and the human, like we like to call them. So the brain being the pre-trained model, which is kind of the raw, pre-trained, unsupervised pre-trained versions, the 7B, the 13B, and the 70B. We then, fine-tuned them as well as used RLHF to align them, and then release those as the chat versions. And as you can see from the quotes to the bottom, the pre-trained one doesn't do that well. But once you actually align it using RLHF, it actually does quite well. So you can see, are there good reviews for Crocs? Does anyone wear Crocs? I don't wear Crocs, but okay, a few people, a few brave souls. So the answer there is like Crocs are a brand of shoes. Crocs come in many colors. Crocs live in swamps, and crocodiles are scary. So obviously, it's conflating the animal, with the pair of shoes, whereas the human version, or what we call the fine-tuned RLHF version, does quite a bit better because it's been human aligned. And then if you actually look at what we call kind of the employee, your proprietary data, which I'll talk more about using these models, you can then fine-tune even further on your own data and actually customize quite a bit, and even align it more towards what you want to do, maybe as a business or in your particular application. So at the highest level, using Llama means a bunch of things. One is it's open. So you can basically, under the community license, and we have an acceptable use policy, you can take these models, you can download them, you can fine-tune on your proprietary data, and then you can actually deploy them, again, as long as you follow the license, as well as the acceptable use policy. And that's actually kind of a game changer, because you can take these models and actually deploy them in your Mac. There's actually someone building a tiny Llama. I don't know if anybody follows me on LinkedIn or whatever, but I posted a few weeks back somebody building a 1.1B version of Llama. You can deploy these things in different devices locally, and that actually is one of the best ways to preserve privacy. Second, obviously it's free. We're not charging a license fee for it. We've actually paid all of the human costs, as well as all of that expensive pre-training, all the compute. We've paid all that, and so the model is free to you. It's pretty versatile. We have a 7, 13, and 70B. We're looking at other checkpoints in the future to release. And then lastly, it's a very safe model. So one of the things that I personally love about the generative AI space is it's a little bit of a revival of the responsible AI, of responsible AI, full stop. Not that we didn't care about responsible AI in the past, but it definitely didn't get the attention by the community that I'd say it's getting today. So red teaming, safety evals, this is becoming something, or has become really something that is absolutely critical to release these models. It's not optional anymore. And you can see from the paper, our models are really safe. If you compare them to open alternatives and even some of the closed alternatives. We took this really serious, and there's a lot of red teaming we've done and a lot of safety filters that we have on the model. And it's become something that is absolutely critical path to us releasing models. And as I mentioned, these models actually perform quite well. So we're not quite, as a community, I would say, all the way there on model evaluation and what it means. We have a bunch of kind of, interesting benchmarks that people will evaluate on. And I would say none of these are perfect, or even together, they're not perfect. It's such a high area of entropy in the space. But today, this Llama models actually perform quite well. A little bit about the license. So again, our community license is pretty permissive. It supports both research and commercial usage. You can make derivative works. There was I think over the weekend, I answered, I don't know how many issues on GitHub about using it with the Chinese language. Can I fine tune on Chinese and use it? Yes, you absolutely can. So for the record, you absolutely can, as long as you follow the acceptable use policy, and you can absolutely deploy that model if you wanted to in an application. The license allows that. Just again, follow the AUP. There is a 700 million MAU restriction, but I imagine like 99.99% of folks don't actually need to worry about that. And if you do have to worry about that, then you're doing pretty well. And then lastly, I want to talk about just Code Llama really quick. So this was actually the first model that we had built that's on top of Llama 2. Has anybody played with Code Llama yet? It's pretty cool, right? So this actually came, this is one of our partner teams in FAIR, built this. They took Llama 2 and they further fine-tuned it on code. It basically is capable of generating code, and you can actually prompt it with natural language about code. So you can actually ask questions about your code. So it kind of supports both code and code generation as well as natural language prompting. Again, same license fee, or same license usage, I should say, as Llama 2. No fee, it's free, research, commercial usage. Comes in a bunch of different flavors, including the foundational code model, Python, as well as an aligned instruct version. And from our evals, we saw that it's state of the art. And again, this is available. You can download this as well. It's on Hugging Face and so on. Cool. I'm going to shift gears and talk actually code and cloud TPUs. So I have, again, my friends from Google here. They'll answer all the hard questions. I'll just stand up here and look good and present some slides. So one of the things that's really cool about the Google stack is that it is actually built basically on open source. So all the way down to the Ray orchestration, to OpenXLA in the compiler space, to PyTorch XLA, which is a project that was actually co-founded by myself, actually, back when I was at Meta, working with Google on building a bridge, essentially, to accelerating hardware. So that was cloud TPUs. And so it started out as a Google Meta project and has since grown, and Amazon and others have joined, and it's been pretty successful. On top of that, there's, of course, the native PyTorch library, which I'm near and dear to my heart, and then, of course, the model itself, which is Llama 2. So very much an open source stack that they're building on. So getting into a little bit of code here, because we are at Ray Summit, we should talk Ray and actually show a little bit of code. And I won't dive into every line of code here. I just want to kind of show a few different things I think that could be interesting as you're optimizing your code. By the way, all of this is open source. Alan, sitting right here, maintains that repo, and there's notebooks and all kinds of things that you can play with. So one of the things that's really cool here is, has anybody heard of OpenXLA and PGRT? You don't count. You're the product manager. So basically in OpenXLA, there's this concept of a runtime, and basically how do I say this? It runs really fast. So PGRT is basically if you use the new runtime in OpenXLA, you will get a speed up. You probably don't need to know how the sausage is made underneath. You just basically plug in the code, set it to TPU, and it will run much faster. In this code here, we're just importing a model from transformers, pretty standard stuff. We're importing Torch XLA, which again is a bridge to getting down to accelerated hardware, in this case, cloud TPUs. We're actually using SPMD, which basically enables auto parallelism, which is really nice. So if you want to scale, for example, like to hundreds or even thousands of TPUs, literally, you just did it. It was done for you. There's a lot of magic that happens underneath. And then once you kind of get into the Ray world, so let's talk Ray, because we're, of course, at the Ray Summit, you can add things like the decorator here called Ray Remote, and then basically wrap that in what's called an actor, and that enables basically fault tolerance for your training. So if anybody's actually trained anything at any kind of reasonable scale, has anybody trained like on 1,000 GPUs, for example, or like 1,000 TPUs? Probably a few. Okay, you guys don't count again. A few hands. Okay, has anyone had a job go down? Has anybody had like a node go down? You have, of course you have, because, So, it's bound to happen. So fault tolerance is actually something that is actually pretty critical because, we're pushing the state of the art in these models and training these things on, not only 1,000, but 10,000, sometimes 50, even 100,000 I've seen, in some of like the bigger training runs. So, a node going down or a cluster of nodes going down actually can be incredibly detrimental. And, the proof is in the pudding here, actually. The performance, so, MFU is model flop utilization. Has anyone heard that term? So model flop utilization, basically, are you getting the most out of your hardware? And 52% may not sound like it's actually a lot, but it actually is. It's actually pretty state of the art. I've seen kind of roughly 20, 30%, and probably even worse on code that kind of is out there in the open. This is highly optimized code, so you can actually take this work from the Google team and actually leverage it and not have to worry about it, and you're getting the great performance. On inference, a couple things are interesting when you're using Rayserve. So who's using Rayserve in actually a production environment? I know you're Anyscale, so but still good to know. Okay, a few folks. So auto-scaling is actually pretty important when you start to talk about multi-host serving. These models are so big, you need to think about distributed inference and sharding these models and defining basically a way to scale a number of replicas, et cetera. Literally, it's a couple lines of code to do that here. In terms of maximizing throughput, you can actually pump your batch size up, and in this case, the second line of code here, you can actually maximize that, and I'll show some benchmarks here in a second. I actually like Rayserve a lot because it's very simple. Basically, you can pretty much wrap anything and turn it into a server, into a deployment, and it's actually pretty easy. If you know Python, basically, you can use Rayserve. So again, proof is in the pudding. There's really two ways to consider success here. One is throughput. So that's really like tokens per second per chip. In this case, is normalized on a perf per dollar. So looking at V5, which V5 is the latest and greatest that was just announced a couple of weeks ago at the Cloud Next. You're seeing on the 70B a 2.5x speed up in perf per dollar, which is pretty impressive. And then in terms of latency, which is really important for application, responsiveness and so on, especially as you're talking to these models, you're literally talking to these models, you want latency to be as low as possible. Latency on the new generation is actually on the order of 1.6 or 1.7 x lower, which is really impressive. So finishing up, I think I have just a couple of minutes, and I'm glad to answer any questions. A couple of calls to action. If you go to GitHub, you go to PyTorch-TPU/Ray Llama, you can get all of the code, everything that's here. There's notebooks, everything there is available in the open source. And then for Llama itself, go to ai.meta.com/llama. Our papers there, our benchmarks are there, acceptable use policy, responsible guide, all that stuff is there. You can read all you want about Llama and learn more about it. And just a quick shout out to the team at Google, Milad, Alex, Alan, Shaheen, and the rest of the folks. Appreciate all the support, especially putting all these slides together. It's really, really appreciate it. Great work, guys. And from that, I'll happy to answer any questions.
Thank you so much, Joseph. We have 1 or 2 questions.
Should I go back to the cool Llama? The intimidating Llama, blue. Where is it? There it is.
I was just wondering how Meta is planning, or what Meta is planning to do with the Llama ecosystem going forwards, and how whether Meta has any plans to monetize it, or what they're sort of expecting to see.
So, this is coming from the guy who worked on PyTorch for many years. So we never monetized PyTorch, obviously, and I don't think we ever really have a plan to monetize Llama directly. Although it's a good idea. But I think at the highest level, I think we want an open community around this. I'll give you some examples. Model safety and I would say red teaming is something. Trust and safety is not something that I personally see as a competitive advantage. And so I think one of the things that I'm excited about, being open about our technology, is it allows us to kind of make this a team sport, make it a community, something that the community can invest in. If you follow my commits on GitHub, for example, you can see some of the updates I've done on our repo, and we've found some stuff with Llama that that people have, they can jailbreak these models, and you know what? That's okay. Our models aren't bulletproof. No one's models are bulletproof today. And so what this, I think, allows us to do is actually kind of understand around those corners, like what's coming. And I think that's really important for companies building with generative AI. And we get, feedback quicker. We understand, I think, the challenges much quicker because we are open, because we are collaborative. Same with PyTorch. When, back in the day when computer vision was going crazy and the CNNs, if you remember, the CNNs kept scaling up and we're like, what's going on here? It was, ResNet and ResNext and all the different types of models kept changing. That gave us kind of a lingua franca with the community. We started to just evaluate those and build better products based on that. The same thing with Llama. When new things come out around safety evals, we can quickly leverage that. If you look at all of the optimization work, there's that guy in Bulgaria, GGML, the GGML folks. They've accelerated Llama models, I think, more than anyone, and they've open sourced their code. That's some really great work, and we can certainly leverage that, and we can support them, and obviously in kind and so on. So I think for us, there's just so much value in the world building on our stack that helps us, and obviously we give back by open sourcing our technology. So it's really something that is mutually beneficial. I mean, with kind of PyTorch and Llama, and we collaborate with OpenAI on Triton, for example. That's kind of this pretty standard stack at the center of AI. So it's pretty nice to be there at this point. Hopefully that answered your question.
Hi. So I know Meta previously released a model, OPT, Open Pre-trained Transformer. And I know you guys went into pretty good detail about how you trained the model, like the size of the cluster you use, the type of GPUs, and the training techniques like fully sharded data parallelism.
Yep.
And I was wondering kind of if you knew what kind of techniques you used for training the Llama model at Meta. Like, did you guys use FSDP again? And did you use the same A100 GPUs?
I mean, we have a 48-page paper that goes into excruciating level of detail. And I think if you've read that paper, and I think was it Sebastian Raka, I think did a tweet on this that just went a little bit viral. I think that paper was more transparent than I think any other model that was out there. Yeah, OPT was kind of it truthfully wasn't, I would say, the best model when it came to end performance. But the meticulous way the team kind of logged every single aspect of the training, it was almost like a journey reading it. It was just wild. Susan and that team did an incredible job. I would point to the paper, to be honest. The details, who isn't using FSDP these days or whatever, right? So there's just pretty standard techniques. Inference, there's a bunch of things that have become pretty standard, things like LoRa and QLoRa and speculative decoding. There's just all kinds of things. We of course experiment with the state of the art, things like second order methods, maybe not in this particular one, but we are for the future, like shampoo and things. So, but yeah, I would definitely read the paper. It's got a lot of detail in it.
Thank you so much, Joseph. Another huge round of applause for Joseph.